Here we have version 7 of Dash module number 2. I have here a version 7.1 and a version 7.2. They're very similar, but there are a couple of differences that we need to point out. First of all, if we look at the rear of the unit, you can see that on version 7.1 we had larger terminals, screw terminals for the power connections. We found that wasn't actually necessary, so now in version 7.2 and onwards we have the same size connectors used throughout. Also, the version 7.1 has actually an additional connection, an additional screw terminal. There are 38 on version 7.1, but only 37 on version 7.2. And the main reason for that is that we discontinued the use of the CAN bus interface, which we never used. These chips here were a CAN bus, serial CAN bus interface, and we never used it. We also had a socket for an additional serial EEPROM, which was never used, so they came out. The voltage regulators are also different that are used on the two units. Version 7.1 uses the 7805 regulators. Version 7.2 uses a slightly higher current device. You can see on both of these units that we have a under voltage sensor, which was initially used as the means for storing the odometer and trip meter readings when the unit was powered down. We used this device to produce an interrupt to tell the microcontroller to store the trip and odometer readings from RAM memory back into EEPROM before the power completely disappeared. But we found that wasn't a very reliable method, and we now use a different method entirely, which is to store those readings back to memory when the speed reading goes from a non-zero value to a zero value. So in actual fact we can remove these devices altogether now. They're still present on these units. A couple of modules also see version 7.1 has a wire link between the G segments of the speedometer display, because that was missed off the artwork, and a current limit resistor for the speaker, which was also missed off. Version 7.2 corrected the missing links between the G segments, but still needs a current limit resistor. We also have, in terms of mods, some minor connection links on the D-type connector to make it compatible with earlier versions. So let's look now at hooking up the unit and seeing how it functions. Let's look at hooking up the necessary switches and potentiometers. We're going to connect to a test rig by a 25-way D connector, but let's put that aside for the moment and let's take a look at the other connections that we need to make via these screw terminals. We're going to connect a latching switch and two momentary contact normally open push buttons. In the video we'll be referring to a short push and a long push on each of these switches. A short push corresponds to just pushing and releasing the switch in less than a second. A long push corresponds to pushing and holding the switch for about 2 seconds. You'll hear different confirmation beeps depending on whether you do a short push or a long push. And we'll hear that in the video. But in terms of these switches then, here's how we connect them on the version 7.1 version of the module. We have a common between each of these switches, and that common is going to be connected to the last screw terminal counting from right to left, and on version 7.1 that is terminal number 38. There's actually one more terminal on here compared to version 7.1, so that's 38 on here, but it's going to be 37 on version 7.2. Let's look at the other connection from the latching switch, which is the non-common one, and that is going to be connected to pin 17, which is one of the ground switched inputs. The non-common input from push button number 1 is going to be connected to pin 18, and the non-common input from push button number 2 is going to be connected to pin 19. Regarding these potentiometers, we've got one terminal which is common between them, and that's going to be connected to pin 23. This is counting right to left from here. This is 1, 2, 3, 4 and so on. So that's pin 23. Potentiometer number 1 is going to be connected to pin 22, and potentiometer number 2 is going to be connected to pin 24. Notice also that there's a short wire link between pins 26 and 27 that's necessary to enable the onboard speaker. If you don't connect that, the speaker won't work, but the reason for that is so that you can use an external speaker if you wish. So we either put a link in here to enable the onboard speaker, or we put no link in there and we feed the speaker between pin 26 and ground. So the connections on version 7.2 of the module are very similar, except as we mentioned a little while ago, there is one fewer connection, one fewer screw terminal connection on version 7.2, primarily because we removed the CAN bus function, which we never used. So this is a standard pin app now that we use across most of the modules. So again, the common connection for the 3 switches, that is the latching switch and the 2 push buttons, is the last connection counting from right to left, but this time it's pin number 37. The last connection is pin number 37 on here. The latching switch itself, the non-common terminal, connects to pin 17, counting 1, 2, 3 to 17. Push button number 1 is connected to pin 18, and push button number 2 to pin 19. Regarding the potentiometers, the common is again connected to pin 23, potentiometer number 1 connected to pin 22, and potentiometer number 2 to pin 24. Again, we have this short link between pins 26 and 27 to enable the onboard speaker. Okay, so here we have the module hooked up to a latching switch, which is the black one, 2 momentary contact push buttons, the red ones, and 2 potentiometers. But right now we have the latching switch in the off position, the 2 push buttons not being pushed, and the 2 potentiometers on maximum resistance. So it's just as if right now there's none of these connected. We also have the module connected to a test rig, which is going to allow us to simulate the various sensors that would be hooked up on the car. So let's go ahead and power the unit up. And the first thing that I want you to notice is that when we do power up, the current version of the software will be displayed momentarily on this 4-digit display at the top. So you see that it displayed 1.05, that's the software or firmware version that's currently loaded into this module. You'll also notice that on the display we have an odometer and a trip meter. The odometer can be used to display miles or kilometers, as can the trip meter, and the speedometer can be used to display miles per hour or kilometers per hour, as we'll see shortly. Also, you'll see on the display that we have a couple of 20 element bar gauges. The upper one we generally use to indicate engine temperature, with the lower one we generally use to indicate fuel quantity. I say generally because the module accepts 3 analog inputs, that is engine temperature, fuel quantity, and also it measures the supply voltage, and either one of those 3 analog inputs can be selected to be displayed on either one of those 2 bar gauges. So let's actually adjust on the test rig the temperature signal input, and we'll see that the upper gauge will move according to that input. We also have on these 2 bar gauges range checks, and if the temperature, for example, goes out of range on the high side, we'll get a warning, which will be an audible warning, and the diagnostic LED, which is this one above the bar gauge, will flash. So let's continue to increase the temperature out of range. You can see that we have the audible indication of an exceedance, and we also have the diagnostic LED associated with that bar gauge flashing. Let's bring the temperature signal back into range, and you'll see that the flashing indication now stops. So these diagnostic LEDs then, when they're on continuously, that means that the signal is in range, there's no problem, and when they flash rapidly, that indicates an out of range condition. The fuel gauge, we deliberately put a bit of a lag on this so that it doesn't move up and down rapidly when you're going around corners or where the car's moving. So if I actually move the fuel gauge signal input, there will be a significant delay before that moves. Obviously the fuel quantity isn't changing that rapidly, so we don't need that gauge to respond very quickly. In fact, we don't want it to respond very quickly, otherwise it would be all over the place when you're driving the car. We obviously don't have a upper range limit on the fuel indication. We don't mind having the fuel tank full, so there's no need for an upper range indication on that. But we do have a lower indication. So if we take the fuel quantity completely down, because there's a long delay on it, it will take a while to go down. But if we do bring the signal right down, you'll get a similar kind of audible warning and flashing on the diagnostic indicator that we saw when we put the temperature on the high side. So let's just continue to bring that down. In fact, you'll get the audible warning probably before you see the gauge go low, because the audible warning and the flashing diagnostic indicator work on the live value, whereas the display that we're seeing here is working on the lagged value. But I'm moving it very slowly, so you don't really notice that. Okay, so fuel gauge goes low, you get an audible warning and a flashing indication. Temperature gauge goes high, you get an audible warning and a flashing indication. Let's look now at some of the other indicators we have on here. We have a set of 3 indicators here. Well, let's just mention this one as well. That's like this one here is another diagnostic indicator, but it's used to indicate an overspeed condition on the road speed, and you can set that to any value that you want, just to give you an indication if you're overspeed, if you're going too fast. So this set of 3 indicators here, we use the center one to indicate high beam, headlights high beam, and we use the outer ones to represent left and right turn signals. These red-green pairs here we use to represent a number of conditions. In fact, they're just high switched inputs, where right now on this version of software we have green representing a high input and red representing no input or a low input. We're probably going to reverse that because it makes more sense to have red indicating power. So the first one, let's just switch these off for a moment. The first one represents power is being applied to the ECM. The second one represents that the ECM is providing a high switched output to the fuel pump relay. The third one represents that the fuel pump relay is actually producing a switched output, and the fourth to the fuel pump fuse, and the fourth one represents that the fuel pump fuse is providing an output to the fuel pump itself, so the fuel pump fuse is intact. So if anything breaks along that line, we can diagnose what the problem is by which of the LEDs is green and which is red. For example, if the fuel pump relay were being driven but not producing an output, those two LEDs would both be red. If the fuel pump relay was producing an output but the fuel pump fuse was faulty, that LED would be red. The fifth one we generally use to represent the reverse lights. The fifth one we use to represent fog lights. And the fifth one we use to represent rear window defogger if we have it connected. Now, not everyone is going to want to hook up the connections for all of these indicators that we mentioned a moment ago. So the software incorporates what we call user options, and more about that in a later video, but one of those user options allows the what we'd call the secondary indicators, these non-essential ones, to be put into a dummy mode as opposed to being functional. In that case, these non-essential functions would just display a random pattern, but the essential functions, the ones which are necessary for the road test, the annual test here in the UK, such as the turn signal telltales, the high beam telltale, and the fog lights telltale, they would all be functional. So we can distinguish them into two separate groups and just have the essential ones functional if we wish. Let's now go ahead and apply a speed signal to the unit. You can see that we have a bar gauge at the top, and we can actually double the sensitivity of the bar gauge to make it more colourful at lower speeds. And now that we have a speed signal connected, you'll see that the trip meter on this upper left 4-digit display is incrementing, and the trip meter displays to the nearest tenth of a mile. The odometer, which you can see just incremented a moment ago, is displaying to the nearest mile. The trip meter can be reset at any point by a long push on push button number 1. So push and hold, and it will reset to 0. Now the value, the total mileage on the odometer and the value on the trip meter are stored every time the unit is depowered, and the point at which they're stored is when the speed is seen to go from a non-zero value to a 0 value. So if we switch off the speed signal now, you can see that it will count down, and when it reaches 0 you'll hear a momentary beep, which you can disable as a user option if you wish, but it just confirms, listen, there, do you hear it? That just confirms that the odometer and trip meter value stored in memory have been updated. So if we now power the unit down and power it up again, you'll see that those values that were reached before have been stored. You can see that right now the unit is displaying odometer and trip meter in miles and the speedometer in miles per hour. We can toggle between miles and miles per hour and kilometers per hour by a short press on the second of the two push buttons. So like that. You now see that we can toggle between them at any point. So 15,518 miles and 0.9 miles become 24,829 kilometres and 1.5 kilometres. Now, unfortunately, the 7-segment display doesn't allow us to display miles or kilometres or even M or K. So the symbol we've used to represent which mode we're in is a U to mean UK or US, which are using miles and miles per hour, and a C for Canadian units, for example, which is pretty much everywhere else in the world. So let's go back into proper units, miles, for a moment. And let's talk a little bit more about this 4-digit display at upper left, because we can do more with that than just show a trip meter value. We've seen some of the functions we can change. This second push button here, we've seen that a short push on that can toggle between miles and kilometres, and we've seen that a long push on push button 1 can reset the trip meter. A short push on push button number 1 allows us to change the function of this display. Right now we're in trip meter mode. A single short push will put us into displaying the fuel as a numeric value. You can see that the fuel gauge is displayed as a bar on this lower gauge here, but we can also display it numerically, and we can change the units between gallons and litres. So right now we're displaying 8.1 gallons. So let's just tweak the fuel gauge as we did before, and as before there's a bit of a delay on it. In fact, it's quite a long delay on it. You can see that that numeric value is going up. Again, these user options that we'll talk about in a later video can be used to define whether we want the numeric display to be in gallons or litres, and we can also change between US gallons and imperial gallons. Let's bring that fuel gauge down a bit more. Let's do another short push on push button number 1, and we'll get a temperature reading on here, which is at the moment showing 211, 212 degrees. Let's change the temperature reading, and you can see that now the numeric display is moving with the temperature gauge. And again, user options allow us to change that between degrees, Fahrenheit degrees, and degrees centigrade or Celsius. Another push on push button number 1 allows us to display the supply voltage. Right now 12.5 volts. Let's tweak that a little bit up to 13.7 volts, 13.8 volts, and you should find at some point that we'll get an over voltage condition, and the over voltage condition is indicated by the audible tone again, but this time a flashing on the miles per hour indicator. Let's bring it back into range, and let's take the supply voltage low this time. Let's take it down to about 10 volts. You can see that again we get an indication of an out of range condition. So for voltage we get out of range indications if you're too low or too high. For temperature we just got an indication if you were too high, and for fuel we just got an indication if it was on the low side. Okay, so these push buttons again then. Short push on push button number 1 changes the function of the 4-digit display. Long push on push button number 1 resets the trip meter. Short push on push button number 2 toggles between miles and miles per hour or kilometers and kilometers per hour, and we'll see that a long push on push button number 2 actually puts us into what we call show mode. Before we do that though, let's continue with more pushes on this push button number 1. We've had trip meter, we've had fuel, we've had temperature, we've had voltage. Further pushes allow us to select additional functions which are transmitted on the unit's serial data bus. That's getting a bit too much information for this video, so we'll look at that in a later one. And we have potentially three alternative signals which can be transmitted on the serial data bus. And we've just indicated the difference between them by 1, 2 or 3 bars on that last indicator. Another push, and we can put that display into a show mode, a demo mode, and it's just counting numbers up and down. Another push will actually freeze the display, and it will allow you to transmit any bit pattern you wish on the serial data bus. Another push brings us right back round again to the trip meter mode. So let's now, as we mentioned a moment ago, do a long push on push button number 2. We now go into show mode. In show mode, all of the displays just cycle round some pattern which can be chosen. We have a default pattern, but we can set that depending on the customer's specification, and we can also put any message down on this this message center at the bottom, which is normally the odometer. So we've just chosen some pattern which we can use up to 256 characters on there. Okay, one other thing to show on here then is the brightness control. So you can see that we have two potentiometers hooked up. One of the potentiometers controls the brightness of the numerics and the 20 element bar gauges, whereas the other one controls the brightness of the LED light bars. We can actually use a single potentiometer to control the entire display, but we also have the option of separating the two out like this. So let's vary this potentiometer. And you can see that that one controls the LED light bars right off, and we can bring the brightness up gradually to full brightness. And the other potentiometer controls the numerics. And as I say, we can combine those together into a single potentiometer very easily. So long push on push button number 2 again will put it back into the functional mode or normal mode. You see that we get a temporary indication of what mode we're going into as well. Okay, so that's the normal running mode and the show mode covered. We're going to talk a little bit more now about how to get into the various modes, and we're going to look at two other modes which are very useful for diagnostic purposes. The two main modes that you will use are show mode and normal running mode that we've just looked at. We're going to now look at two other modes, which are input test mode and output test mode. But before we do, we'll talk about how we actually select the modes. There are two ways that we can use to select the operating mode that the module goes into when we power up. One is by going through a menu option, and the other is by just holding down one or two of the push buttons when we power up. Let's first of all depower. It's best to explain it by doing it, isn't it? So the first way we'll look at is by using the menu mode. Now the menu mode is enabled by having this latching switch in the on position when we power up. So if I put that switch on and power up, then this time, instead of going straight into a particular operating mode, it's going to display on the 3-digit display the mode that it's going to go into if we then push button number 2. But if we push button number 1, that allows us to cycle through the options. It'll start off with NOR, which is normal mode. If we push button number 1 once, it'll show SHO, show, which is show mode. push it again, OTS, that's output test mode, and push it a third time, input test mode. Push it again and it'll cycle back round. So we can use this push button number 1 to cycle round the 4 possible operating modes. And when we've reached the mode that we want, let's say we wanted to go into show mode, then we'd push button number 2 and that mode would be selected. And there you can see we've gone into push button, we've gone into show mode. Let's depower again. And now let's go into this output test mode. So again, we'll power up with switch, the latching switch in the on position, and we go into the normal mode. Let's cycle around the modes until we get to the desired one, which is output test mode, and press push button number 2. Okay, so we are now in output test mode. What output test mode does is it exercises individually each display element to make sure that each and every display element can be driven on its own without affecting any of the others. Now, the potentiometers, the brightness control potentiometers, don't have any effect in this mode. We just want everything on full brightness. We're just trying to work out if everything works. And in fact, one of the tests, which we'll see shortly, is to vary the brightness of the display. So we don't want any potentiometers affecting that. So you can see it's now testing each and every element on the display, including the red-green indicator pairs, the speedo bar gauge, and it's now trying the whole display, make sure the whole display can be lit together, and it's now varying the brightness of the numerics to maximum brightness and back down to minimum brightness again. And now the LED light bars up to maximum brightness and back down to minimum brightness again. It's now going to test the onboard tone generator to make sure that it can generate all the tones. And then it's going to cycle back round again. Let's depower, and we're going to power up now in input test mode. So output test mode enables us to make sure that the microcontroller can drive each and every output. We now want an input test mode, which enables us to check whether the microcontroller can see each and every one of its inputs. So back to the menu mode, and we're going to select input test mode and select it. Now, input test mode. These two displays here and these displays here represent the hexadecimal value of the reading from the analog to digital converter on each of the analog inputs. These two at upper left here represent the potentiometer positions. So you can see as I vary the potentiometer, brightness control potentiometer, that goes up and down, and it's also reflected on the upper bar gauge. The second of the potentiometers is that second pair of digits there, and also displayed on the lower bar gauge. The left hand of the 3 pairs here corresponds to, what does that one correspond to? The fuel gauge. So there's the fuel gauge, which is going between a value of AA in hexadecimal and 01 in hexadecimal. The center number represents the reading of the A to D converter for the temperature. And that final pair corresponds to, as we might expect, the supply voltage. So this enables us to make sure that the microcontroller is seeing all of its analog inputs, and of course all the digital inputs as well, all the discrete inputs. These function in just the same way as they do in normal mode. It also allows us to measure whether the controller is seeing the switches as well. So, for example, this indicator here in input test mode represents the status of the latching switch. This one represents the status of push button number 1. This one represents the status of push button number 2. And the display, the numeric display here, actually represents a counter, which just enables us to look at whether it's seeing pulses. It just counts from 0 to 255. So that's just the speedometer signal. But instead of displaying speed, it's just counting pulses from the speed signal generator. Okay, so let's switch that off again. So that's getting into the various modes using the menu. The alternative way of getting into the various modes is to have the latching switch off, and as we've seen, if we have the latching switch off and neither of those push buttons pressed, then it will go straight into normal running mode. However, if we power up with push button number 2 held down, it'll go straight into show mode. If we power up with push button number 1 held down, it'll go straight into output test mode. And if I have enough hands to do this, if we power up with both of these push buttons held in, it'll go into input test mode. So those are the two methods of selecting the mode. Either power up with this switch off and a combination of these switches held in, or power up with this switch on and then use the menu to select the desired mode. So that's a very brief overview of what has turned out to be quite a complex unit. We're going to need more videos and more explanation to give the detail of the other options that are available within the software, but that is essentially what we need to know to actually get the unit up and running.